All right, so we're looking at the answers. A is 1,320. B is permutation. 2A is 720. 5,040. 151,200. Then as we go down, this is 78. This is combination. This one is C, and this one is J. What questions do you have over page 1? Okay, so number 3, you walk into the store and you need to buy a combination for your bike. And there are 13 different colors, and they're so beautiful. They're like metallic colors. And you're like, oh my gosh, I don't know which one to pick. And you need 2 of these locks, maybe to lock your bike up in 2 different places, or you just have 2 different bikes or something like that. And so is you picking, you're going to pick 2 of them. You pick pink and green. So you take pink and green and you go to the register and you pay for it. Is that any different than you picking green and then pink? Is pink green different than green pink? No, it's no different. So that means order does not matter when you're choosing locks from 13 locks. The order doesn't matter. So on this one, you would do 13, and then you would choose combination, and then 2. Okay? Looking at the other side, we've got 8, 24, 720, 720, 6,360, 90, 2,184, 120, 3, 336, 91, 462, and 2,300. So remember, you always ask yourself first, does order matter or does order not matter? 2 students are headed to the office with the papers in hand. 3 students are headed to the office. Does it matter which order you say their names in? If I say Taha, Kwan, Tahani, is that any different than me saying Kwan, Tahani, Taha? It doesn't matter whose name I call first. Those 3 students are going to the office to bring the papers. So this one's definitely a combination. There's 25 students, so it's 25. You're doing combination, and you want to choose 3 of them. Order does not matter, so that's why it's a combination. What else? Number 5. Hey. Number 5. Oh. So you know that you can just put it in your calculator, but if you wanted to do it by hand, then 9 factorial minus 6 factorial would really be 9, 8, 7, 6, 5, 4, 3, 2, 1, minus 6, 5, 4, 3, 2, 1, over 9 minus 6 over 3 factorial, like that. But these are being multiplied, so be careful, because they're being multiplied, so you can't just cancel them out. You put it in your calculator. Maybe you didn't use parentheses correctly. Your numerator would have to have parentheses around it, and then your denominator would need to have parentheses around it. So 9 math factorial minus 6 math probability factorial is 3, 6, 2, 1, over 3 times 2 times 1. Divided by 6? Yeah. So it's that divided by 6, and that gives you that right there. So it's probably just a parentheses thing. What else can I go over from your homework? Okay, so we're looking on number 5 back on the other side. There are 7 slots in the bike rack. Rosalie arrives at the same time as 2 other cyclists. How many ways can they arrange their bikes? That word arrange should be an indicator. It should be a key word. It should set off something in your brain. Does order matter or does order not matter? If you're arranging something. If you're arranging these bikes into slots, the order is going to matter. So it's going to be a permutation. There are 7 slots, and how many bikes are there? Well, there's Rosalie's, and then there's 2 more. So Rosalie plus 2, 1 plus 2, there's 3 bikes. So how many ways can you arrange 3 bikes into 7 slots? And the answer is 210. Okay? All right, so let's get to today's lesson. Today we're actually going to find the probability of things. We are actually going to see what is the likelihood that something happens instead of just saying, how many combinations are there? So probability, how likely an event is to occur. Sample space, the set of all possible outcomes. So I'm going to be using those words, probability and sample space. So if I have, this is actually not a normal dice, but pretend this is a normal dice. If I have a dice, what is the sample space of my dice? This is actually a really cool dice. It's like glittery. I don't know if you can tell. It's glittery. So the sample space would be all the possible outcomes. So on a regular die, oops, I didn't mean to write that. The sample space would be 1, 2, 3, 4, 5, 6. Because there are 6 numbers on a standard die. The sample space is like a list. It's a set of all the possibilities. What's the sample space when you have a quarter? What's the sample space of a quarter? Yes, Jenny. So the sample space of a quarter is heads and tails. So when I say sample space, I'm not asking really for a number, although I realize you were saying how many options there were. The sample space is the list. It's a set of all the different things that could happen. Okay? So, here's an example. Oh, I already went over this example. But anyways, the probability that you will roll any number on the die is 1 out of 6. The sample space is 1, 2, 3, 4, 5, 6. Okay? What's the probability that I roll a 1 or a 2? The probability I roll a 1 or a 2, well, that's 2 of the items in my sample space. So that would be 2 out of 6. So that would be a 1 in 3 probability. Okay. So what is the probability of something happening? It's the number of favorable outcomes over the number of total outcomes. So I think about it like this. It's the favorable over the total. Favorable over the total. Total number of outcomes in your sample space. Favorable over total. All right, so each letter of the word probable is written on a separate card. Instead of cards for you guys, I have this thing up here that every time you click it, it's a different letter of the word probable. Anyways, the cards are placed face down and mixed up. What's the probability that a randomly selected card is a consonant? So first you have to know what a consonant is, right? Now when I'm finding the probability of things, I always do the total first, because that's always, we want to make sure that our baseline is good, that our total is correct. So what is the number of items in the sample space of probable? How many items are in the sample space? P-R-O-B-A-B-L-E. 8 letters, right? How many of those letters are consonants? So a consonant is a letter that is not a vowel. I bet you know what a vowel is. A-E-I-O-U. A consonant is a letter that is not a vowel. So there's 5 consonants. Very good. So the probability of picking a consonant is 5 out of 8. If you can reduce that fraction, you have to reduce that fraction, but we can't reduce that one. let's just talk about all the different forms that you can put probability in. You could say the probability is 5 out of 8. You could also write it as a decimal. And you could also write it as a percentage, 62.5%. Okay? Sorry, I'm closing the door because that was getting loud. Okay, now let's actually conduct the experiment. Let's see how many times we get a consonant out of 8 times. Let's do it 8 times since our denominator is 8 right here. So we'll do vowel, consonant. All right, so I'm just going to click this 8 times. 1, oh, I got a vowel. 2, that's an L, by the way, so that's a consonant. 3, I got an R, that's a consonant. 4, vowel. 5, consonant. 6, vowel. 7, uh-oh, vowel. And 8, consonant. Oh no! What we just did was called experimental probability. We actually did the experiment, and it didn't happen 5 out of 8 times. It happened 4 out of 8 times. Not a big deal. Not a big deal because we were only 1 off, right? So instead of 62.5% of the time, it happened 50% of the time. So how far off were we? We were 12% off. Okay. 2 number cubes are rolled. What is the probability that the difference between the 2 numbers is 4? So the first thing we have to do on this problem is we have to figure out what our sample space is. We're not just rolling 1 die. We are rolling 2 dice, 2 number cubes. So I put this picture up here to show you a visual. These are all the different options that we could come upon. We're assuming one's red and one's blue just to see the 2 differences, okay? So how many items are there in our sample space? So this is a 6 by 6 grid. So there are 36 different combinations or different ways that we could roll 2 die. 36 is our denominator. Now, how many of those, when you subtract them, do you get 4? How many of them? You could just find them on the chart. 5 minus 1. So then we'd also need to grab 1 minus 5. What else? 6 minus 2. So we have to do 2 minus 6. Sound good? Anything else we can make a 4 out of by subtracting? Okay, so how many favorable outcomes are there? 1, 2, 3, 4. I circled 4 of them. Yeah, we are counting order. There are 4 favorable outcomes. We would never leave our answer like that because that is reducible. And so the probability would be 1 out of 9 times. The difference would be a 4. It's because they're 2 different number cubes. Now, let's talk about a different way we could have gotten that denominator. How else, would that be a permutation or a combination? Another way you could think about the sample space is that how many options are there for dice number 1? There's 6 options. And how many options are there for dice number 2? There's 6 options. So if you didn't have this cute little visual on your worksheet, that's how you would have gotten the denominator. You would have said, well, okay, on this die there's 6 options, and on this one there's 6 options. I've got a total of 36 options. We did that yesterday when we were doing like the small cakes thing. If you've got, 3 types of cake and 5 toppings, how many mixes are there? Well, we did 5 times 3. This one you've got 6 choices and 6 choices, so 6 times 6. All right? Each student receives a 5-digit locker combination. What is the probability of receiving a combination with all odd digits. All odd digits. Okay, so you would kind of start through your reasoning. When we talked about digits yesterday, when we're trying to choose a number, we've got options 0 through 9. So how many options are there? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 10 options when you're choosing a number. Well, how many of those options are odd? Well, 5 of them. 1, 3, 5, 7, and 9. 5 of those are odd. So that, if you want to reduce it, you can reduce it now or you can reduce it later. You've got a 1 in 2 chance that any one of those digits is odd. Now, it's a 5-digit locker combination. So, on the first digit, you've got a 1 in 2 chance. On the second digit, you've got a 1 in 2 chance. On the third digit, you've got a 1 in 2 chance, so on and so forth. So what this really is a 1 in 2 chance raised to the 5th power. So 1 to the 5th power is 1, and 2 times 2 times 2 to the 5th power is 32. So you've got a 1 out of 32 chance that all of the digits will be odd. Very good. Some get it in high school. You don't have enough lockers in high school for every student, so I think it's like the freshmen get it or something. You get lockers if you're in like football or dance or any sort of sport. Okay. A DJ randomly selects 2 of 8 ads. When I say ads, I mean like an advertisement, right? Okay. Like commercial. Think of it as a commercial. To play before his show. 2 of the commercials are by a local retailer. What is the probability he will play both of the ads before his show? So it's like he's got recordings of 8 different businesses. Pick a business, let's say McDonald's, okay? 2 out of those 8 recordings are from McDonald's. He just grabs 2 recordings from the stack. What's the probability that he grabs both of the McDonald's recordings to play? Both the McDonald's commercials. That's what it's saying. So what we need to do first is we need to figure out how many items are in our sample space, right? Now, this one's a little bit different because the sample space is not that easy. The sample space is not just 8. The sample space is saying, how many ways could I choose 2 out of 8? Now, is it a permutation or combination? Because we need to know that to get started. So this one is, does it matter which one he grabs first if he's going to play both of them? Good, good. It doesn't matter. So this is, we've got 8 commercials, and we want to do a combination, and we want to choose 2 of them. 8, choose 2. That's going to tell us how many different outcomes are in our sample space. So 8, math, probability, go down to number 3, and 2. So there are 28 ways to pick 2 of the 8 ads. So that's our denominator. I always start with the denominator. Now here's where it gets tricky. Now you want to select both of the McDonald's. Both of the McDonald's commercials. So that's kind of like saying 2, choose 2. Because I've only got 2 commercials from McDonald's, and I want to choose both of them. Go to your calculator and find out what 2 choose 2 is. There are 2 of them, and I want to choose both of them. What is 2 choose 2? Yeah, there's only one way to choose both of those. So the answer is, the final answer is 1 out of 28. 1 out of 28 times he would pick both of the McDonald's commercials to play. Yeah. So you need to have that one in your notes to look back on when you do your homework. In your homework, you'll find one that looks just like this one, and you'll do it the same way we did it so that you can practice it at home. The numerator one, okay. Okay, so there's 8 commercials, and let's say 2 of them are McDonald's, and let's say the other ones, I'm just going to put other letters for the other ones. That's commercial A, B, C, D, that's 4, 5, 6, E, F. So there's all the different commercials he could play. Now when I'm trying to figure out how many choices I have, he could play McDonald's and then Company A. He could play McDonald's and Company B. I mean, there's 28 of these. He could play BE. He could play CM. He could play FM. He could play AF. I could sit here and I could list 28 combinations. I could list 28 of them. What I'm asking is, when I list all 28 combinations, how many of those will be MM? How many of those will be choosing McDonald's twice? Only one out of all the 28 ones that I list will say MM. Because remember, order doesn't matter, so picking McDonald's is no different than picking the other McDonald's commercial and then the other one. I'm sorry if I'm lagging. So that's what it's saying. Out of all the different combinations, only one of those combinations says M and M. Okay, the next thing that we're talking about is experimental probability. So we already kind of did this one earlier when we actually did the experiment of drawing the letters in the word probable. The experimental probability is the number of times it occurs over the number of times you try it. So this is a lot like it is in science. You make a hypothesis, then you conduct an experiment, and then you kind of go back and you compare it to your hypothesis. Was I right or was I not right? How far off was I? So the number of times the event occurs over the number of trials that you do. So how is theoretical different from experimental? So in theory, if you've got a coin and you're flipping a coin toss, in theory, it should land on heads 1/2 of the time. In theory, it should land on heads 50% of the time. But the experimental probability would be you actually conduct an experiment. So you flip it and you get tails. How many times do you want to do this? Flip it and you get heads. Oh, look, we're 1/2. Flip it and you get heads. Flip it. Oh man, I'm doing good. I am totally living up to the theoretical probability. Oh my goodness. I've never seen it be so perfect. Okay, there we go. I got one that wasn't perfect. Okay, so the theoretical probability is 1 out of 2 times. The experimental probability is I did this 8 times, and I landed on heads 3 out of 8 times. So this is the theoretical, and this is the experimental probability. And if I asked you to find the difference in the theoretical and the experimental, you would simply subtract them, the larger minus the smaller. So 1/2 minus 3/8. So if we did that, 1/2 minus 3/8, we would get 1/8. The difference in the two is an 1/8. So a very small difference because I was almost perfect. All right. This is the last one we have. These are our 3 teachers that teach Geometry K at Cy Falls. So what we are going to do is talk about, in theory, how many times should we get Miss Tanton's face, and then we'll do the experiment and find out the difference. So in theory, how many times should we roll my face if there's 3 Geometry K teachers? Right? There's 3 of them and there's only 1 of me. So in theory, we're supposed to roll my face 1 out of 3 times. So if I click it, that's Miss Iguade. How many times do you want to do this one? That's Miss Vestal. Miss Vestal. Oh no! We're not rolling me at all. Oh my goodness. We'll do it 10 times. Oh, there we go. 3, 4, 5, 6, 7, 8, 9, 10. Okay, so the theoretical is 1 out of 3. The experimental is 2 out of 10, which is 1 out of 5. So what is the difference in the theoretical and the experimental? I would do 1/3 minus 1/5. And so we were 2/15 off. 2/15 when you subtract them is what you get. All right?